Conference. So I'm now going to hand over to Elisabetta Scaglia from the Italian tannery industry, and she's going to deliver the Procter Keynote Memorial Lecture on chromium tanning and Chrome 6, the present situation, future evolution, and related problems and possible solutions. Thank you very much, and please welcome to the dance Elisabetta, who's going to be on screen, hopefully.
Can you hear me?
We can hear you.
Okay. Can you see my screen?
We can, but not the presentation. You're still on the.
No, not yet the presentation, because it takes a little bit time, because a huge presentation. huge in the sense that there are many pictures. So.
Sorry.
No, please.
Do you want to ask?
Tell me.
Oh, could you turn your camera on as well, so we can see you?
Hey!
Hey.
This is what I'm seeing online.
Right, so just show.
Yeah. I haven't transitioned yet.
No, please.
This is why I said don't close it, Elisabetta.
It went perfectly. Half an hour ago, it's not possible to open it now.
Tell us what happened, Elisabetta.
No. Oh, yes, okay.
Okay, thank you very much. I'll give the floor to you.
Okay. So, good morning, everyone. I'm so sorry not to be there. I was really honored to be invited to this conference, and I think I have done my best in order to show you which are the main problems and the main advantages related to the use of chromium in the tannery when we are tanning leather. I'm Elisabetta Scaglia. I work for UNIC, the National Association of Tanners in Italy, and I'm responsible of everything is technical in the tanning production, from dangerous substances to tanning problems and final articles problems. Well, what's wrong with this? Okay.
Elisabetta, do you want to maximise it and put it on full screen?
Display view. It's not in display view.
Yes.
Perfetto. Grazie mille.
Okay. Okay. No. Why? Okay. Well, I'm going to present a general overview about chromium problems and possible solutions, starting from general introduction on chromium and chromium tanning up to the problem of chromium 6 and possible solution about the presence of chromium 6. So there are many topics that are related to the use of chromium, and I hope to give you a general idea about what is happening in the industry and the market on this topic, and which can be the future problems and the possible solutions. First of all, is something that has to be clear is the fact that we need to understand if chromium is or is not a problem for health and environment. What we can say as a general overview about chromium production is the fact that chromium is the First and foremost about abundant element in Earth crust that is present in every kind of living being, in atmosphere, soil, vegetation, fresh water, seawater, sediment, everywhere. And the most important ores, chromite, are concentrated and produced in South Africa. There are also ores in other parts of the planet, also in Europe, but they are not used. They are closed. One other thing to say is that the 32% of industrial use of chrome is used in our sector, in our industry, and we only use chromium free, and it is also a macro element that is fundamental for human being, because it's at the basis of sugar metabolism, in particular glucose metabolism. And on the other hand, the other form of chromium is the more oxidated one, that is chromium 6. This one is not that simple or easily to be used, because it's very toxic, and it is banned from the use at least in Europe, as it is, because the fact is it is classified as a first class of carcinogen in the UNIC classification, that is international organization about that is involved in on cancer research. So it has been agreed all around the world that the safer a safe concentration in leather for chromium 6 is 3 ppm, and is this is an agreement that is valid at present all around the world. How chromium is involved in leather tanning? First of all, is chromium 3 involved in the tanning process and not chromium 6. Many years ago, chromium 6 was actually the first step for producing chromium 3 in tanneries, and then chromium 3 was used in tanning process. But nowadays, chromium is directly mined and provided as chromium 3 sulfate. This kind of tanning has been developed at the end of the 19th century. Before it was mainly used vegetable. They were mainly used vegetable tannins, and the starting of use of chromium, trivalent chromium, the tanning process has been very much increased because of the fact that the use of chromium 3 represents a very easy way to produce leather, is very well studied, has a series of properties that allowed recovery of the carbon bath, for instance, the possibility to have the tanning process only by using a change of pH is very much applied when there is a not homogeneous lot of bide wet glues. And at the end, the bond that chromium 3 has with with the collagen contained in leather is a reversible reaction. So it's not that fixed. It's not a fixed bond. So as it is reversible, there are many opportunities to recover chromium and collagen once we have scraps or waste that needs to be recovered. As I said before, Chromium 6 is not longer using leather tanning process. Anyway, there is a possibility to have an oxidation from Chromium 3 to Chromium 6 at certain conditions, but it's always an equilibrium. A reaction equilibrium between chromium and chromium 6 that is more shifted to chromium 3 than chromium 6. This equilibrium depends on many factors, for instance, pH, concentration, presence of oxidants such as O2 or O3, and sometimes actually this oxidation occurs also in the leather when it's finished. On the other hand, chromium 6 is a very strong oxidant, and in normal conditions in which leather is produced, chromium is completely present in the reduced form of chromium 3, at least if there are residuals of chromium 6, they are very low and well below the limit of 3 ppm. Chromium 6 can be formed only under drastic actions of temperature, presence of oxidation agent, UV radiation, and the presence of radicals that are molecules that can connect as improvement factors of the oxidation of chromium 3. Why are the positive aspects of using chromium 3 in tanning leather? First of all, it has been very well studied along a couple of centuries. So all chemicals developed during this period are particularly adapted to be used on chromium 3 tan leather. And for instance, as the reaction between chromium 3 and collagen is reversible, and chromium 3 has different behavior depending on the pH of the solution in which is solved. Is it possible to recover chromium 3 from the bath of chromium tanning, and after a proper treatment and cleaning process, is possible to be reused in tanning phases. Another positive aspect of chromium 3 tanning is the fact that, for instance, shavings, so something that in theory should be a waste, actually can be recovered because of the fact of this very easy to be cut bond between chromium and collagen. In this case, proteins in general. In this case, proteins and collagen can be reused from cosmetic industry down to agriculture products that can be used instead of fertilizers. Something about the equilibrium between chromium 3 and chromium 6, just to understand why our clients don't want, at least are starting asking for a chromium free or metal free leather tent. As you can see, I'm sorry, the slide is in Italian. This is has been a co-production between our National Association of Chemical Producers and our association, and it's a slide. It's a picture extracted from a guideline that indicates how to avoid the formation of the oxidation of chromium 3 to chromium 6. And as you can see, which is always an equilibrium between chromium 3 and chromium 6 that is mainly shifted to the part of chromium 3 presence, but at certain conditions. And what has to be said is that if chromium is bonded with collagen, it is rather impossible to be oxidized to chromium 6. It is said, and we think, that the part of chromium that can be oxidized to chromium 3 to chromium 6 is the part of chromium 3 that remains unbonded inside leather, and at concentration above 200 ppm of extractable chromium 3, extractable chromium 3, there is a higher possibility that this chromium can be oxidized to chromium 6. However, always in strong oxidizing condition that can depend on temperature, on humidity, irradiation, presence of radicals that I remind you that are organic compounds that can accelerate the reaction of oxidation between starting from chromium 3 to chromium 6. So it seems that the possible presence of chromium 6 in leather is mainly due to the presence of some greasing, some fat liquids that have insaturated bonds in the hydrocarbon chains. And they are not in itself a problem unless the leather that has been fat liquid with this kind of fat liquids can be exposed to strong oxidizing conditions such as UV radiation, so exposure to the light, long exposure to the light, or long exposure to temperature at dry condition. Always keeping in mind that the presence of water is something that reduce the possibility of oxidation from chromium-3 to chromium-6. Chromium-3, salts of chromium-3 perfectly dry can oxidize to chromium-6 in presence of this kind of cut liquids. If they are solved in water and with the same kind of cut liquids and exposed in the same conditions, the temperature, UV radiation, etc., 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 they can show any type of oxidation to chromium-6. Sorry. So we can try to summarize which are the main causes of oxidation of chromium-3 to chromium-6, and which are the conditions that can reduce this possibility. So the first one is try to limit the use of unsaturated fatty acids, such as fish oil, for instance. Avoid the use of ammonia prior to the dyeing process. So after, if you receive wet blue, if you treat wet blue, after the retanning phase, if ammonia is used, there is a high possibility that the chromium-6 is developed. Try to limit the use of substances that can lead to oxidizing condition in the leather. Try to avoid the exposure to UV, to the light, after the leather has been completely produced, after the finishing phase, when it's sent to the clients, because UV can increase the presence of radicals that are those organic molecules that can improve the oxidation, the possibility of oxidation to chromium-6, and try to avoid exposure to high temperatures when there is a low concentration of relative humidity. Another thing to take into consideration when you are speaking about chromium-6, and this is one of the problems that we are dealing with in this period for the evolution, because of the evolution of the legislation, is the fact that, as Paracelso said, everything can be a poison and nothing exists without poison, but only the dose considered or used ensure the fact that the poison behaves as a poison. I made a simple example. Inside hemlock and parsley, there is the same kind of molecule that is a poisoning. But the concentration in the hemlock is very, very, very high, so it's a poison. While the parsley contains a very small part of this molecule, and it has been used safely unless you eat 2 kilos of parsley. That is not very, very easily that occurs, that fact. And what about the possibility to have an effect at workplace on the human health? This is from chromium-6, always from chromium-6. There are limits that have been established by a directive that sets a limit value for the exposure of workers at the workplace, and this quantity is rather low. It's 0.01 milligram per cubic meter. This until January 2025, and after that date, this limit will be reduced down to 0.005 milligram per cubic meter of air. Every analysis made on workers at workplace demonstrate that the levels that are evaluated, even with the worst method possible, because it's not a method for detecting chromium 6 in leather, but it's a method for detecting chromium 6 in industrial dust in general. Demonstrates that chromium 6 leather, chromium 6 concentration is far below the limit that have been set by the European Commission for chromium 6 at workplaces. So with the proper DPI and aspiration, vacuum devices that are placed where chromium is weighted is very effective, and the presence of chromium 6 at workplace is really manageable. And then we pass to another very big problem related to chromium, that is the detection of this chromium in leather. Up to 20 years ago, more or less, there was a habit to shift methods used in other industrial sectors, such as textiles, for example, and they were used for other matrices that weren't leather. And okay, if it works for textiles, of course it works also for leather. This is not true, and a big work has been done in order to rewrite all the methods, including the one for chromium 6 detection, by validating these methods for exactly for leather. And this exercise has been made by the normalization European organization, that is SEM, and in which the technical committee of leather, that is a 289, has developed and assessed and validated, I think, more or less 100 methods between chemical methods and physical methods. It's been a big job, and then these methods are perfectly aligned with IUC, IUP, etc. methods. So nowadays they have the same text, and they are all reliable when we analyze leather. And a problem related to the chromium 6 method of analysis. There are two methods. The first one is 17075.1, and the second one is EAN ISO 17075.2. The first one is a colorimetric method, and second one is a chromatographic method. And here there is an explanation about what kind of results we can have. They can be both accurate or precise, or inaccurate and imprecise. Accurate, well, let's start with precise. Precise is the are the results that are more or less the same, that are very narrow as figures, when different laboratories analyze the same sample. Another possibility is to have an accurate results when that is the picture in the down left corner, when results are near the hypothetical true results, but are not very narrow one each other. Imprecise and inaccurate is a mess because results are not narrow, the theoretical result, and are not very narrow as figure in the results. And the best option, that is what we all dream, is the fact that the results are accurate and precise, so they are very similar, even if produced by different laboratories, and are very narrow to the true concentration, the hypothetical true concentration. Now, the method we have nowadays, up to now, assure the 3 milligrams per liter, 3 milligrams per kilo of concentration. That is the limit set by the Commission for leather. And the problem is only related to chromium 6, because chromium 3 is not a problem, not for it's not a problem for health, and it's not a problem when it is analyzed, because there are many methods to be used in order to assess the content of chromium 3, also because the fact that chromium 3 is present in the entire leather in a huge amount. We are talking about grams per kilo, while when we talk about chromium 6, we talk about milligrams per kilo. So it's another couple of fish. We say the first part is the method 17.075 part 1 is a colorimetric method, so it's subjected to interference due to the presence of colorants and other interference and problems. And while EN 17.075 part 2 is able to detect and separate different species of substances in order to select only chromium 6 present and have a more reliable results. In any case, we can say that the first method is really not good method. It's good if it's used, for instance, for check the internal production of a tannery producing chromium leather, but it's not at all reliable for detect chromium-6 in order to assure the compliance to the legislation. While the second part, the chromatographic method, has a good accuracy and a bad reproducibility. That means that if leather is analyzed by different laboratories, the consequence is that the same sample can have a pass in the case the concentration is below 3 ppm, while another laboratory can say, well, it doesn't pass, it's a fail because the concentration we found is above 3 ppm. This is because the error that is made when the concentration is around 3 ppm is about 50%. So when we read 3 ppm, we are not sure that we are reading 3 ppm or 1.5 ppm or 4.5 ppm. We can have this kind of variation because of the fact that this method has a bad reproducibility. So, in this moment, we have, as we said, 3 ppm as a limit in the legislation. I'm aware that half hour is already passed, so I'm trying to cut it to. Oh, what happened? Sorry, but I have more or less finished. Okay, and possible future scenarios for SC is linked to an EC proposal to drop the concentration of chromium-6 from 3 down to 1 ppm in the during the next years. And this is really a problem, even if we think that at the same time we are on the there are several other restrictions that are under proposal that are bisphenols restriction and glutaraldehyde restriction, and that could be really a problem. We think that at the end of the day, the last dangerous and the last problematic substance to be used in tanning process is chromium. This is because the example we made before is easily to be recovered. It is easy to be recovered as bath and from waste, etc. So, while other substances are not that easy to be handled. Which are the related problems? Well, related problems to the fact that there is this proposal to reduce the concentration from 3 to 1 ppm, concentration of chromium-6, of course. The existing methods are unable to detect chromium-6 below chromium-3 concentration. This is the first fact. So, if a limit is set at 1, the competent authorities won't be able to understand if the check they are they are applying are actually true or not. They want to be able to assess if a company is compliant or not to the legislation. There are the possible alternative to Chromium, to the use of Chromium. We said that are glutaraldehyde, bisphenols that are all in the crosshairs of legislation. And something that is up to now is not to be have not been taken into consideration, but vegetal tannins are wood powder, and wood powder, hard powder of hardwood is considered carcinogenic. So also tannins, vegetal tannins, can be a problem in the future. Possible solution. At political level, we are trying to avoid that this restriction is applied at least for during next few days, few years, excuse me. So in order to have more time to check if there are alternatives and if there is the possibility to avoid chromium free oxidation to chromium 6. We are doing strong lobbying actions towards national authorities in order to explain them that there is no possibility to check if this limit is respected or not, because we don't have an appropriate method. Possible solution at technical level, the first one is trying to find something that avoid the oxidation from chromium 3 to chromium 6, and we as UNIC are working on this with some university in Italy, and there is an exchange of information also with Northampton and WISE on this matter in order to try to avoid this occurrence. And the other one is, if there will be this reduction, at least we are able to detect chromium 6 down to 1 ppm with a reasonable certainty of being in the right around of the true concentration. And what we are going to do is to find an effective oxidant. So, what's up? So, how to fill the gaps that there are on the market on these problems? There already are existing guidelines to avoid the chromium 6 oxidation. So you don't have to do this, you have to do that, etc., etc., etc. Those ones that have been agreed between us and our National Association of Chemists, but they are not applicable to all kinds of leathers, particularly fine leathers such as aniline or lambs or very smooth leathers are affected in the final aspects, for instance, by using 2% of percentage of Tera. Usual antioxidants, for instance, ascorbic acid alone, are not always sufficient to protect chromium-3 to chromium-6 oxidation. And this depends on pH condition and use of particular chemicals, etc. What we have already done is try to combine ascorbic acid with other antioxidants that are mainly phenols or phenols compound, and we are experimenting salt of what is Yes, and we are trying anti-oxidizing at the moment only on chromium sulfate salts, and we will pass to leather in the next few months. Preliminary results said that, for instance, at the same temperature and humidity conditions, liquid salts of chromium are more subjected to oxidation than those that are in a solid state. And for example, a long exposure to a medium temperature, around 40 degrees centigrade, has a more effect on the chromium oxidation than a short time of exposure to a very high temperature, such as 80 degrees centigrade, always with a low content of relative humidity. And this is all. 3 minutes in advance of time I had in my response. Okay, thank you very much for your attention. And if there are questions, of course, I'm here to answer you. I don't know.